Hello all. Today the top program we are going to discuss is about displaying upper right triangle and lower left triangle of a matrix. So first I will explain the concept, what is upper right triangle and what is lower left triangle. So here I have taken a square matrix. So this is possible only in the case of a square matrix. A square matrix means a matrix whose row size and column size is equal. So this is a square matrix. So it is having a size 3 by 3. So a 3 by 3 matrix. So totally the number of elements will be 9. 3 into 3, that is 9. So you can, I have marked the position of each element. The first element is 20, the position is 0 0. Second element is 10, position 0 1. Third element 15, position 0 2. Fourth element 30, position 1 0. Fifth element 25, position 1 1. Sixth element 20, position 1 2. Seventh element 40, position 2 0. Eighth element 35, position 2 1. And ninth element, and the final element is 5, and the position is 2 2. Okay, so upper right triangle means the elements that lie above the diagonal element. So these are the diagonal elements 20, 25 and 5. The elements marked in inside the dotted line represents the diagonal elements. So the upper right triangle represents the diagonal elements as well as the element that lie above the diagonal elements. So upper right triangle includes 20, 10, 15, 25, 20 and 5. And lower left triangle means the opposite. That means the elements that lie beneath the diagonal elements, including the diagonal elements. So the lower left triangle represents 20, 25, 5, 30, 40, 35 and 35. Okay. So we have to display the, first we will see how to display the upper right triangle. Okay. So you can see that there is a peculiarity in the position of the elements that comes under the upper right triangle section. So can you analyze whether there is any peculiarity? If you analyze the I and jth value of each element, you can see that the upper right triangle, if you take the first diagonal elements, the position is 0 0, 1 1 and 2 2. That means I and j, the values are equal. And if you take the other elements above the diagonal elements, you can see that the positions are 0 1, 0 2, 1 2. So here you can see that the if I represents the row indexing and j represents the column indexing. I is always less than j. Here I is 0, j is 1. Here I is 0, j is 2. Here I is 1, j is 2. So I is less than j. So the elements that comes in the upper right triangle section can be represented as I less than or equal to j. So likewise, if you analyze the elements in the lower left triangle, you can see that diagonal elements, as I said before, positions are same. Other elements, you can see that I is 1, j 0, 2 0, 2 1. That means I is greater than equal to j. So this is for upper right triangle and this is for lower left triangle. And if a program comes to display the sum of diagonal elements, then you can just check whether I is equal to j. If I is equal to j, then it represents the diagonal elements. I is equal to j represents the diagonal elements. Okay. So next we will see the program, how we are going to display the upper right triangle and lower left triangle. So first I have declared the necessary variables. I have declared a 2 by 2 matrix, a two-dimensional matrix of size 10, 10. And first I have asked to enter the row size and column size, and it is being saved to variables R and C. So as I said before, this is possible only in the case of a square matrix. So I am checking whether R is equal to C. So if R is equal to C only, you can display the upper right triangle and lower left triangle. So if R is equal to C, I have asked to enter the elements, and using a for loop, I have scanned the elements to the matrix A of I, J. Okay. So for the outer loop, I have given the condition I less than R, and for the inner loop, I have given the condition J less than C. So if you give R in both the cases also, it will work because the value of R and C are the same. So then I have displayed a message upper right triangle, and inside a for loop, I am checking whether if I less than equal to J. As I have said in the example, upper right triangles are represented by I less than equal to J. So if I less than equal to J, I will be printing those values only. Printf %d A of ij. In all other cases, if I is greater than J, in all other cases, I have to just print a blank space. That is what I have done in the else part, else printf blank space. So in those positions, there won't be elements. It will be vacant. Only these elements will be displayed, and it should be displayed in a matrix form. So I have closed the else part, and I am printing a /n to print each row. Means after each row, it should move on to the next line. So for that, I have displayed a new line character, and I have closed the outer loop. Okay. So same, if you take the case of lower left triangle, what will be the difference? Instead of I less than equal to J, you have to give I greater than equal to J. So that I have mentioned here. Printf lower left triangle for I equal to 0, I less than R, I plus plus. For J equal to 0, J less than C, J plus plus. If I is greater than equal to J. If I is greater than equal to J, the same thing you have to do. Here I have displayed A of ij. Else just print a blank space. Then close the inner loop, and outside I have print a new line character to display each row. After finishing this row, you will be moving on to the next row. And here I have given a if condition. If R is equal to C, then only you will be displaying the upper right triangle and lower left triangle. If this condition is false, in else part, I have given else it is not a square matrix. Okay, and I have closed the main program. So this is how you display the upper right triangle and lower left triangle of a matrix. And if you want to display the sum of diagonal elements, program is the same, just the for loop part is different. Inside for loop, what you will be doing, if I is equal to J, as I said before, diagonal elements, their position are the same. Okay, so if I equal to J, I represents row indexing and J represents column indexing. If I equal to J, then I have added those elements only to the variable sum, and I have displayed the value in the variable sum to show the sum of diagonal elements. So this is the program to display upper right triangle and lower left triangle of a matrix. Hope you understood. Thank you.